Hello, this is Mrs. Scarpel, and in this video I'm going to take you through the process of finding the linear regression line or the line of best fit for a scatter plot using Desmos. And then I'm also going to take you through the process of identifying the slope, identifying the y-intercept, identifying the correlation coefficient, and interpreting those values, as well as using the equation for the linear regression to make predictions. So to begin, this is the data that I am going to use for my scatter plot. So I'm going to go to a spreadsheet that has this data, and my slide said it was L9A2, and we are looking for this particular set of data here on the left, lesson 9, activity 2. I do a copy or a control C to copy those particular cells. And then when I go into Desmos, I just have to do control V in that first space. So we have our scatter plot. This I've talked about in a prior video. Now to get the linear regression is as simple as the click of a button. If you look up here to the left of the table that I've entered into Desmos, you'll see the 4 dots with a line through them. Kind of looks like a line of best fit for these points. That's how we get our regression. So I just click on that, and we are only worried about linear regressions right now, so I'm just going to leave this as linear regression, just like it is. And then you see here that we've got one equation. We've got y equals negative 32.96429x plus 402.5, and we've got the r value, the correlation coefficient, of negative 0.75. Now, let's just review a little bit about that correlation coefficient. Because it is negative, I should see a downward trend in my data, which I do. 0.75 is moderately strong. It's not overly strong. As you can see, we don't have our points all close to this line, but it's not all spread out either. So it's a moderately strong, I should say that again, a moderately negative correlation coefficient. And just to take another look at what my data was, it was years since 2001 and area of deforestation. So I'm just going to add those labels to my scatter plot. So I go to my graph settings. My x-axis was the years since 2001. So I just type that in the label for the x-axis. And we said area of deforestation, and that's in thousands of hectares. It's a measurement for the area of land. So now you'll see that we do have those labels on our graph. So year since 2001, area of deforestation, we've got an equation that goes with this line that was drawn in, and we've got our correlation coefficient. So if I go back to my slides, and I'm going to jump ahead here, that regression equation, and it said round to 2 decimal places. So I'm going to have y equals negative 32.96x plus 402.5. So I'm just going to go back to that Desmos real quick, make sure that that's what the equation looked like. Negative 32.96 if I just go to 2 places, plus 402.5. And while I'm here, just double checking that R value is negative 0.75. I believe that one also says 2 decimal places. So we're going to say that R equals negative 0.75. Now, before I go to number 3, I do want to point out that the number that precedes or is immediately in front of x is your slope. So negative 32.96 is our slope, and the number that follows, the number that's at the end, is our y-intercept. Because what I'm going to do on the next screen is I'm going to interpret these values in the context of our situation. So we are looking at the number of hectares, thousands of hectares, that are lost to deforestation in the Amazon rainforest. So when I go to 3, we're going to identify that slope, and we said the slope was equal to negative 32.96, and the y-intercept was at 402.5. But I want to give myself some room here because I'm not only identifying them, but it says, what do these values mean in this situation? Another way it could be stated is interpret the meaning in the context. So my y-intercept was 402.5. Now, slope is rise over run. So if we just take another look at this graph, my rise is the area of deforestation over my run is years since 2001. So we're looking at thousands of hectares per year since 2001. And since our slope is negative, that tells me that I'm losing or I'm decreasing the number of hectares. So the the area lost to deforestation, oops, I want to say to, the area lost to deforestation is decreasing. That's what the negative tells me, is decreasing. And because I use the word decreasing, I don't need to include the negative when I write the 32.96. Oops, 96, not 69. 96,000 hectares each year after 2001. So notice I talk about the vertical variable, that's the deforestation in 1,000 hectares, and I include the horizontal variable, which is years after 2001. So when you describe slope, you need to include those two variables. Now for y-intercept, that's where we are at an x value or an input value of 0. Well, our input value is the year 2001. So when I describe the meaning of my y-intercept, I would say in 2001, it is predicted that 402.5 thousand hectares were lost to deforestation. So I'm still including the two variables. I'm giving the input, which is 2001 is the beginning, and I'm giving the output, which is that 402.5 in 1,000 hectares because we're talking area. So that's interpreting the slope and the y-intercept. When we take a look at number 4, we're going to use our line of best fit to make some predictions. So I'm going to go through A, B, and C here, but I'm going to go back to Desmos to do this. But I just want to point out we're going to do this for 2008, which is 7 years after 2001, and then we're going to do it again for 2016, which is 15 years after 2001. So when I go back to Desmos, you'll see this icon right next to equation. What that icon does is it sends the equation to our list on Desmos. So now I have the equation in a place where I can work with it. Well, the x-axis is the years since 2001, and the first one that we wanted to look at was when x is 8. So I'm going to replace x with, excuse me, 7, because 2008 is 7 years after, and if I take a look, when x is 7, I have that value. Excuse me. So we're at 171.75 hectares are lost. So I'm going to write here 171.75 thousand hectares. We should always include a label with our answers to put them in perspective. Well, that probably makes sense. It's a positive value. It's less than the 402.5. And the amount lost was decreasing each year. So now let's see what it is for 2016. That was 15 years later, so I'm going to replace the 7 with 15. And you'll notice that at 15, we're actually at a negative value, negative 91.96. Now, that probably is not a reasonable answer. And I'm not going to just say probably. That isn't a reasonable answer, even though it is correct for the prediction. When you are talking area, you never measure in negative values. So if you think about this situation, 2008 was within the scope of the data. We call that interpolating. 2016 was outside the scope of our data that we received, and we ended up with a negative 91.96. And when it's outside of the data we received or we worked with, it's called extrapolating. So, and if we take a look at our graph, after 2006, when a moratorium on soy production was put into place, or the land that could be cleared for soy production went into place, we see that deforestation pretty much leveled off. So it's probably fair to say that if that trend continued, we wouldn't be down here, and our line of fit would also be changed. So another reason to say why this value isn't a reasonable value. In C, we're looking for a specific year. So we have 303.62 hectares. So going back, I'm going to replace the 15 with the X. Remember, X was the years. So now I want to put in a value for the area. That's my Y value. So I'm going to replace Y with 303.62. Now, while this box doesn't show me what the answer for X is, my graph does. So here's where we're at 303.62, and you notice that's really close to 3 years. So we're just going to go ahead and say 3 years after 2001. But since the question does say the year, we could just say, or the year 2004. So that's how we can use the line of fit to predict, and how we can use it right within Desmos, replacing our variables with the input or output that we have, and using Desmos to find our answers. Number 5, is the line of best fit a good model? Use the scatter plot to explain your reasoning. I would say in this particular case, let me go back to our scatter plot. Remember we said it was moderately strong. In this case, the line probably is a good fit. We have some points above, we have some points below the line. Is it necessarily the best fit? No, but it's probably a good fit for our situation. And then we talked about this. What do you notice happened after the Amazon soy moratorium was implemented? Well, when they put in the moratorium, that's where it leveled off. And that's where our line is no longer going to be good or proper for making predictions beyond that year. So something to keep in mind. So using Desmos is a nice, easy tool to find your regression equation, find your correlation coefficient, and to make predictions with that regression equation without having to take a separate calculator and enter it into the calculator over and over for different predictions. This concludes my video for using Desmos to create and make predictions using the line of regression.